How's it going, everyone? And welcome back to another episode of the Quantum Resistant Ledger channel, your 21st century video portal into the world of post-quantum digital asset security. I am your co-host, Ryan. I am the Director of Advocacy here at the QRL. We are joined by Strike, who is the Director of Outreach. And today we are going to be diving into two primary questions that are kind of follow-ups to what we've been talking about in past episodes. And Strike, the first question I want to dive into is there's been a bit of confusion amongst crypto communities regarding the quantum threat and what it is. So the question I want to pose to you, and just for one for us to dive into today, is where exactly is that threat coming from? I know people's opinions differ on it, but I'd love to dive into where exactly do you see that threat coming from?
Yeah, so there's a lot of speculation online as to, and a lot of confusion as well as to what the threat is and where it actually exists. So it's probably good to clarify some of that and break it down and do some really simple components, which is surprisingly easy to do. So in order to understand where the threat exists, you need to understand a little bit about Bitcoin. So I'll use Bitcoin as the example here. The same concepts apply to altcoins and the rest of the blockchain ecosystem in all likelihood, but we'll use Bitcoin as a reference. So with Bitcoin addresses, a Bitcoin is essentially a 256-bit random number. Now there's different wallets will get to this 256 random bits in different ways, but at the end of the day, a Bitcoin wallet is just a 256-bit random number. That's the first component. The second component is once you have this random number, that is your private key for Bitcoin. From that private key, your computer will perform a function called elliptical curve multiplication. And through this elliptical curve multiplication process, you end up with your public key. And your public key is what you share with everyone else to send to. So where the whole issue comes in is this process between this 256-bit random number, which is your private key, to where your wallet generates from that a public key through this elliptical curve multiplication process. That is conventionally considered to be a one-way function, means it only works in one way. You can take a private key and you can generate a public key, but you conventionally cannot take a public key and generate a private key. So this whole quantum threat that everyone's talking about is the ability to be able to take that using Shor's algorithm and a process called quantum Fourier transform and qubits with a sufficiently powerful quantum computer. You, in theory, can take that public key and then generate a valid private key. So this is less about reusing addresses and a lot of the other things that you hear people talk about online as far as security concerns and not anonymity. This is less about any of that. It really just comes down to this one fundamental part. And in the early days, Bitcoin used to write the public keys into the blockchain. Nowadays, just the hashes are being written into the blockchain. And as far as we know, there isn't a conventional or quantum way to be able to take a hash in the blockchain and then be able to find and then be able to transfer that into a private key. As far as we know, that doesn't exist. But the fact is that public keys are everywhere. They were never really intended to be private. So I mean, they exist. I think I saw something online the other day where it says up to 30% of public keys are within the Bitcoin block space. Within the Bitcoin block space are already known. So, like I said, these were never intended to be private, but it was also Bitcoin was never built around the quantum threat. So this one-way function of being able to go from this one-way function of generating a public key from a private key was never intended or imagined to be reversed theoretically at the time, but with a sufficiently powerful quantum computer, you in theory can do that. So I hope that explains a little bit about the Bitcoin wallet process and breaks that down into something understandable and digestible.
No, I appreciate it. It's kind of it's very complex, but to try to break it down into a succinct answer like that, that really helps. One part that I want to kind of go into is kind of the second and final question just for today's episode is there's been talk, and whether we're talking Bitcoin or Ethereum and how it's tied to the quantum threat of, hey, when the quantum threat, when it reaches a point where it's actually a threat, you hear some people talk about, well, at that point, there's really not a worry. We already have a plan for that. There's just going to be a simple, not a simple, but there'll be an upgrade or it'll fork at that time to something that's quantum secure. But can you dive a little bit into what they're saying behind that? And then actually, what is more of the likely scenario of what's going to happen? Because just saying that you're going to upgrade or, fork to something that's quantum secure, then it doesn't really, if you go onto YouTube or if you're just searching, the interwebs, it doesn't really it's not really a good answer. And I don't think it really answers the question. So could we dive into that a little bit?
Yeah. So if you go online and you start looking at what people are saying regarding their projects, or, if they're, in support of a project, they'll say all of the conversations come down to essentially one thing. And if you distill everything, it comes down to, well, the project will just hard fork. And hard forking is an option, but with many things in life, you have to look below the surface. Hard forking by itself is something that projects do somewhat often, I would say, but the type of hard fork and the projects that would need to hard fork and the scope of the quantum threat are really things that people aren't really talking about. I'll use Bitcoin for an example. If you go online, you'll see, okay, well, is the quantum threat, does that directly threaten Bitcoin? You'll see Pulse. Of course not. Bitcoin can just hard fork. Okay, well, that's not entirely true. If you were to hard fork Bitcoin, the problem isn't really the protocol itself in some sort of consensus model. The problem is the addresses themselves. As we talked about a few minutes ago, you have the private address and then you have the public address. These are the addresses that are in the beginning of the blockchain, are in there now, and this is a fundamental part of the chain. In order for you to go quantum secure in Bitcoin, you'd have to change the entire addressing structure. Now, respective to consensus, Bitcoin does consensus very well with proof of work, right? It uses relatively modern cryptography in order to reach consensus on transactions. But what it really doesn't do as well is consensus for governance of the protocol. This is completely distributed. So, point being, if you were to try and make, let's say there was a sufficient number of people came together in this openly governed project, which is Bitcoin, and they wanted to go quantum secure, you would have to gain consensus, not just on going quantum secure, but the type and way in which you wanted to go quantum secure. And then you would need to find consensus on the code, and then you would need to have everyone change their addresses at some point, and you would have to have everyone upgrade their nodes. Essentially, everything would need to change. I mean, I can't view it anything less than what would be Bitcoin 2.0. So it's not. This type of change would be, I would say the scale or scope of this type of change would be unprecedented in the blockchain community. It's not to say it's impossible. The crypto ecosystem has incredibly dedicated and intelligent developers. There's a lot of creativity in this entire space, with people varying skill sets, all over the world. I definitely see consensus as far as the governance of the Bitcoin protocol in order to reach something that is actually a high quality post quantum secure project. That's where the challenge really is. Some other altcoins may have some advantages in this area. You'll see a lot of, I'll just use Polkadot for example. Polkadot has distributed governance model in which you can go online and you can vote and things like that. And those votes, when you go online, you can see the votes. Okay, I'm proposing this, and the proposals. Bitcoin doesn't have this advanced governance structure with the transparency and things like that. So I mean that becomes a bit of a challenge. I mean you have common repositories and things like GitHub that'll do that, but nothing on change, and just the scale, the number of people that would have to come to agreement, that works really great for consensus of transactions. It becomes quite a bit more difficult once you involve people.
And you bring up a great point too with the governance, and I think that a lot of people are just looking at it from the wrong viewpoint of they're not actually, like, if you look at it actually of what the address is. If you're looking at the public, it's like, if that is public knowledge to other people, then there's a threat to you. Doesn't matter how you're storing it. If that public address is being shown wherever, whether it was in the past or currently. But no, I appreciate you diving into that. I feel like that's a really kind of one that we could talk about for a while. But appreciate you answering a few of these questions. And what we're going to be doing in some of the upcoming episodes, we're going to be diving more into, depending on when you're watching this video, we're going to have the new QRL website launch. It might already be launched depending on when you are watching this video. More exciting news coming up with the move to POS, Enclave, and Strike. Appreciate you taking a few minutes of time to dive into some of these answers based on internal meetings that we're having within the team. And I appreciate you watching. From Strike and I, have a great rest of the day, and we will see you in the next video.
Thank you, guys.
Thank you.
See ya.